I know, it's Alexis. It's just crazy. You know how to do it? All right, we will do it later. I think I'm back to where I need to go now. Okay. So, all right, we did this problem. So, once again, just reminding everybody and chat on the video, when we have a base of 3 and a base of 6, they are not related to each other. We're going to solve and get an answer that's in terms of logarithms. Okay? You can use the common log base 10, log base 3, you could use log base 49 if you just, felt the need. Okay? So, all right, let's go from there. What was the next one someone was asking about? Number 6. Number 6 says, you invest $1,200 in an account that pays 6% annual interest compounded continuously. How long will it take your investment to triple in value? So this is definitely one where you definitely want your calculator fueled up, high on good, solid batteries, so we can work this out. And it's straight up telling you here to use the formula. You need to know those formulas for tomorrow. Thursday, tomorrow. Okay. So if A equals P times E to the RT, we have P equals 1,200. We have R equals 6%. And we're looking for the time for our investment to triple. T is unknown. So if we're starting with 1,200 and we're trying to triple our investment, we want A to be 3,600. So basically, I know everything but T. So let's go for T here. And I probably should zoom out. There we go. Okay? So we're going to set up everything and solve it. So 3,600 equals 1,200 times E to the 0.06. All right, don't have a brain malfunction and write 0.6, okay? Be on the lookout for that. T, so divide both sides by 1,200, and we get 3 equals E to the 0.06 T. So, once again, Emily, we are going to undo an exponent with a logarithm. They're inverses of each other. So when I take, in this time, I'm choosing specifically the natural log because I want to help myself by getting rid of that E. The natural log of 3 equals the natural log of E to the 0.06 T. Well, first of all, that will come down to the front, and E to what power is E? 1. So that cancels out. So ln of 3 equals 0.06 T. So from there, I'm going to divide both sides by 0.06. Now, let's think about this for just a minute. We're after time. We're talking about time to triple. Anticipate what the answer is going to be before we do anything here. We want to triple our money at 6%. It's going to be a few years, is it not? Think about that, okay? But if you get some outrageously small number, does that make any sense whatsoever? If you get 36,000, would that make sense? No. So I'm just trying to get you to anticipate an answer before we even type anything in. So ln 3 divided by 0.06 gives us T equals 18.31 years. That makes sense. That makes sense, okay? So anticipate what a reasonable answer should be before you even do anything, okay? That is number 6.
The number 5 formula, is that just
That's just the other formula. And, I would write it A equals P 1 plus R to the T. I believe that's correct, okay? They're just doing it here based on what they're asking for in that particular problem, okay? All right, anybody else on the log sheet? Number 2 right back up here, okay? Number 2 is 2/3 of 4 to the 3x minus 5 equals -2. This is a great one, Autumn, to just think about. We're solving an algebra equation here, so we have to do inverse operations. So add the 5, and we get 2/3 of 4 to the 3x equals 3. Multiply both sides by 3/2, and we get 4 to the 3x equals 9 halves. Now, from there, we're going to do it just like we did the other problem. So we're going to take the log of both sides. Log. Oh, and you're like, oh, wow, Mrs. Hendry, that's the log of a quotient. So Superman that 3x to the front. So 3x log 4 equals log 9 minus log 2. And then we will divide both sides by 3 log 4. Cancel, 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 cancel. There's your x right there. All in terms of a logarithm or multiple logarithms. Yes. Read the directions carefully, except for those interest problems where, of course, you needed, because you're talking about money. Okay? Money.
It did say for the section that said solve each exponential equation.
Yeah. So, yeah, so since this was another teacher's beautiful work that I stole, exactly. So, all right, because I'm recording, I have to stop for just a second and download this. Otherwise, it goes into those where, it